Assalamu alaikum, dear executives. Hope you are doing good today. So today we are going to start chapter 11 of supply chain management, in which we'll be discussing managing economies of scale in a supply chain cycle inventory. Okay, so what is our learning objective today? First is describe the role of cycle inventory in a supply chain, choose the optimal lot size given fixed ordering cost in the supply chain, evaluate how aggregation is best implemented in reduced cycle inventory in a supply chain, and then understand the impact of quantity discounted on a lot size and supply and cycle inventory. We'll also discuss and devise appropriate discounting schemes for a supply chain, understand the impact of trade promotions, develop replenishment policies, and identify managerial levers. Okay, so first of all, we need to understand the role of cycle inventory in a supply chain. And for that, we have to understand what is lot or buy size. Basically, a lot or batch size is the quantity that a stage of a supply chain either produces or purchases at a time. What is cycle inventory? Cycle inventory is the average inventory in a supply chain due to either production or purchases in a lot sizes that are larger than those demanded by the customers. So we will from here onward using Q as the quantity in a lot or a batch size. D is going to be the demand per unit time. Okay, so this diagram is going to explain to us like this is on here we have got inventory and here we have got the time. So we can see that this is a inventory demanded, and then we'll see another demand after say 10 days. You can see a spike here. Okay, so if this is like 5,000 inventory, then there's a 10 days gap, and then there can be a 10 days gap. Okay, this kind of inventory demand is a cyclic process, and this is the fixed kind of inventory that is being demanded over a fixed time period. Okay, so cyclic inventory is basically the lot size divided by 2. We have given like Q divided by 2. Q is the lot size, and we're going to divide it by 2. Lot means like overall what is the inventory size that we are going to order at one point in time. Okay, so this 5,000 unit is a lot size here. Okay, so we can also calculate from here average flow time, which is going to be average inventory divided by average flow rate. So if you try to work out, and we can get the average flow time resulting from the cycling inventory. So cycling inventory is like Q by 2. You already established as cycling inventory into demand divided by 2, and that's given you Q by 2 D. This will give us an average flow time resulting from cycle inventory. Okay, now take this example. Like for a large size of, like say 1,000 pairs of jeans and daily demand of 100 pairs of jeans, the average flow time resulting from this cyclic inventory would be Q divided by 2 into D. Q is 1,000 units, and D as it's given like 100 units. So 100 into 2, 200, and say 1,000 divided by 200. 2 5s are 10. So 5 days is the average flow time resulting from the inventory, cyclic inventory. Let's recall what is cyclic inventory. Cyclic inventory is the average amount of inventory a business holds to satisfy demand between two replenishments. So when you order in batches, like not in a continuous, inventory rises when the batch arrives and gradually falls as customers buy the product. And if you would like to see the average flow, so we can define average flow time as the average time an item stays in the system. So from the system, the moment it arrives or is produced until the moment it leaves, is sold or consumed. Okay, so let's see what is the role of cycle inventory in supply chain. So if you have lower cycle inventory, it will decrease vulnerability to demand changes, and it will lower working capital requirements, and it will lower the inventory holding cost. The cycle inventory is held to take advantages of economies of scales, and it reduces cost in the supply chain process. Now see, if we want to have an average price paid per unit purchased is key cost in the lot sizing decisions. So if we consider like C as the material cost, and we have a fixed ordering cost as well. So anytime we make an order, like say 5,000 units, and if there are like going to be 5 trucks, they will be involved, the drivers and the fuel and everything. There can be a fixed cost on it. So it includes all costs that do not vary with the size of the order, but are incurred each time an order is placed. So we can call it fixed ordering cost. Holding cost is the cost of carrying one unit in an inventory for a specific period of time. It is called holding cost. So holding cost can also affect the overall decisions when we are trying to make economic order quantities. So we'll be looking for the following cost, which incurs when we make a lot size. So we'll be looking for average price per cost per unit purchased, fixed ordering cost incurred. So we're going to show it with S per lot. So average price is per unit, whereas lot size is per lot, and then holding cost per unit is also going to be holding cost per unit per year. So we are referring it as an HC. And S is for fixed cost, and C is for, and S is for fixed cost, and C is for average price per unit. So the primary role of cycle inventory is to allow different stages to purchase a product in a lot size that minimizes the sum of material, ordering, and holding cost. So ideally, cycle inventory decisions should consider cost across the entire supply chain. In practice, each stage generally makes its own supply chain decisions. So it increases total cycle inventory and total cost in the supply chain. Economies of scale exploited in three typical situations, like first one is a fixed cost is incurred each time an order is placed or produced. The supplier offers price discount based on the quantity purchased per lot, or the supplier offers short-term price discounts or holds trade promotion. So each time we are trying to capitalize upon the economies of scale, we must have either one of these advantages which we are looking for. Again, refreshing economies of scale occurs when the cost per unit decreases as the quantity produced or ordered increases. This happens because large volumes allow a company to spread its fixed cost over more units. So if we increase the batch size, the cost per unit will decrease. Fixed costs can be like setup cost in manufacturing, and they can be any order processing costs, transportation overhead like administration, booking, handling, machine preparation cost, warehouse rent, salaries for permanent staff, etc. So if you take an example, like when a company increases production, how it can decrease the lot size. So if a machine setup cost is 1,000 per batch, so if the batch size is 100 units, the setup cost will be 10. But if the batch size increases to 1,000 units, the setup cost will decrease to $1. We copy paste here so that you can understand. We can paste it here. Okay. So if a machine setup cost is $1,000 per batch, and if the batch size is 100 units, the setup cost will be obviously 10. And if the batch size increases from 100 to 1,000 units, the setup cost will decrease to $1. This is very true for the printing press. So when we were going to go for something printing, and the minimum amount, they will just give you a minimum amount. So say they will say 100 units, you'll have to buy at least 100 units. And they were giving us the price for $10 per unit. But if we will buy more than like 100 units to 1,000 units, and they will sell it to $1 per unit. Why? Because the setup cost is higher. They have to make the print and all this thing. Okay, so summary: cycle inventory builds up in a supply chain because product is produced or purchased in a large lots to lower the sum of the material. It is done for ordering or holding cost by exploiting economies of scale. So opportunities to exploit economies of scale arises if a fixed cost is incurred each time An order to is placed and or produced, the supplier offers price discounts based on the quantity purchased per lot, or supplier offers short-term price discounts. A reduction in cycle inventory improves a supply chain's ability to match supplies with demand. Okay, so let's dig into economic quantity. If D is annual demand of the products, S is denotes fixed cost incurred per order, and C is the cost per unit, and H is the holding cost per year as a fraction of production cost. So the basic assumptions here are that demand is steady at D units per unit time. So there's no huge fluctuation in the demand. So we are just considering a steady demand. No shortage are allowed. So we are going with the fixed kind of demand. Replenishment lead time is also fixed. Okay, so in real world, these things might change, but here we are just going with the basic assumptions, and they will stay stable. So D is the annual demand, S is fixed cost, C is cost per unit, and H is holding cost. So how we can calculate this? Here we have got inventory holding cost minus cost of capital, which is basically a weighted average cost of capital, WACC. WACC is weighted average cost of capital. Let me write down here. Okay. So let's calculate the weighted average cost of capital. The formula is given. E is the amount of equity. Equity we know is basically the owner's equity or their investment into the business. So it is to be divided by the debt, which is the loan they have to pay. RF is basically risk-free or rate of return. So it's a situation in which if they might have not invested into this business, they would have earned a risk-free return. You normally this spend in businesses where you don't have lots of risk, usually based on the government bonds. It represents the minimum return investors expect for a riskless investment. This is like if they put this money in a bank, they would have minimum, say like 5% they would have earned. Okay, what is beta here? Beta is basically, it measures how risky the firm is compared to the market. So if it is higher than, like if the beta value is higher than 1, we will consider it high risky. And if the beta is lower than 1, we will consider it less risky. Normally in finance, we say higher the risk, higher the return. So higher the beta value, we are expecting higher rate of return. MRP is a market risk premium. Again, it is the extra return investors demand over the risk-free rate because markets are risky. So investors don't expect that you will be just paying them the risk-free rate, but they are investing into some business, so they are having high expectations with the business, so they will expect the business is going to give them better return. R naught is the rate at which the firm can borrow money from outside, and T is the tax rate. So if we on this formula, if we try to see again, E is basically the amount of equity that is invested by the investors into the business. D is the amount of debt or loans plus equity. So equity plus the loan is divided by E. RF is the risk-free trade, and B is the beta. Funds beta is the risk margin we talked about. It was how risky the firm is as compared to the market, and MRP, a market risk premium, and then again D plus DOD plus E into RB. RB is the rate of at which the firm can borrow money. So together all this formula gives us weighted average cost of capital. Okay, so what are the inventory holding costs? Inventory holding cost can be the obsolescence or spoilage of the cost. Like the more you hold the inventory, there are good chances that the expiry date reaches quickly. You might have a handling cost, you might have occupancy cost, so you cannot stake more inventory on a limited space. So either you'll have to dispose it off early, and then you can have miscellaneous costs like there are fears of theft, security, damage, tax, and insurance. Then we also have to look about the ordering cost. And ordering cost involve the buyer time, how much time the buyer is willing to give you. Transportation costs are also involved in it. Receiving cost, we know that if they deliver you the consignment, then you'll also have to offload it and stake the inventory. And there may be other numerous costs. The cost of the labor, if you're hiring the fuel, if it is like going up and down. Okay, so if you want to calculate the lot size for a single product using economic order quantity, we'll have to go with basic assumptions. So one of the basic assumptions is that demand is steady at D units per unit time. No shortage are allowed. That is like all the demand must be supplied from the stock. So the orders are already completed and available in the stocks at the factory. And then the replenishment lead time is fixed, like initially assumed to be at the factory. And then the replenishment lead time is fixed, like initially assumed to be 0. So we need to minimize the annual material cost, annual ordering cost, and annual holding cost. This is our objective, so that we can maximize our profit margin. Okay, so if we denote the annual material cost as CD and number of orders per year as D divided by Q, and annual ordering cost as D divided by Q. D was demand and Q was the quantity, and S was the fixed cost. Holding cost can be Q by 2, quantity divided by 2, which was cyclic quantity, and it was the holding cost. It was denoted by HC, small hc. So the total annual cost will be D divided by Q into fixed cost plus Q by 2 into HS, which is again fixed cost per unit plus annual material cost, which is CD. Now this diagram is gonna debrief us like how the cost and the lot size are in inverse relationship with each other. The shorter the lot size, the higher the cost. Imagine if we need if we bring in one truck of, we have trucks, and in one truck we have a capacity of 12 tons of material. We need to bring it from point A to point B. So if we just need 2 tons of inventory, we'll have to use the same truck. So all the costs are going to be the same except the inventory size. So lot size increases numerous kind of cost, and the cost decreases if we go for the large lot size. Then we see the material cost, they remain steady. This is our assumption that, and then we assume that the ordering cost will also lower with the lot size, and it will increase when the order size is going to be reduced. And also the holding cost is an inverse relationship with the lot size. Basically, when the lot size is going to increase, the chances for holding cost will also increase. And the total cost may vary, depends on the lot size. Okay, and it's a cyclic process. It may go up and down. So this is the formula for the economic order quantity for a single product. So what should be the lot size that we need to make? So optimal lot size would be Q and square root of 2ds divided by HC. D was the demand, and S was the fixed cost, and IC is the holding cost. And the optimal ordering frequency would be like how many times we should make this economic order quantity. That should be demand divided by this economic order quantity, which we calculated here. So it will give us, or in other words, we can make it DHC divided by 2C. Okay, here we got the example for this. So the annual demand is, say it's 1,000 unit into 12. So we've got 12,000 units per annum. And the order cost per unit is, say, 4,000. And the unit cost per, say, computer is 500. So holding cost like 0.5. So as per this formula, we will try to 2 into 12,000 is basically D. Okay. DS, and we had C or H. Okay, so using this formula, 12,000 into 4,000 into 2 and divided by 500 into 0.5, it gives us 980 as an economic order quantity. So this is the ideal quantity that we should be keeping, which will not increase our costs. Now, what should be the cyclic inventory? So we know that it has to be economic order quantity divided by 2. So economic order quantity was 980 if it's here. So cyclic, so we are making 2 orders in a year, so it will be divided by 2, so we can make one order as a 490 units. So now, and then we can make them orders per year, so we can divide like economic order quantity will divide demand divided by economic order quantity. So it might give us 12.24 number of orders per year. So almost in a month, we are going to make one order. So almost in a month, we are making one order. It's almost 12 orders we are making. So there has to be a repeat order after every month. So annual ordering and holding costs, they're going to be D, or economic order quantity, into S, or plus economic order quantity, or 2 into HC, which will be 97,980. Average flow time will be economic order quantity divided by 2D, so 490 divided by 12,000, it can be 0.041, which is going to be 0.49 month. So average flow time is the how the energy flows in the system, and how we are going to need fresh inventory. Okay, the key points are total ordering and holding costs are relatively stable around the economic. Okay, the key points are total ordering and holding costs are relatively stable around the economic order quantity. A firm is often better served by ordering a convenient lot size close to economic order quantity rather than precise economic order quantity. Another key point is that if demand increases by a factor of K, the optimal lot size increases by a factor of K. So if the demand increases to the factor of K, it also affects the lot size as well. But the number of orders placed per year should also increase the factors of K. Flow time attributes to cycle inventory should decrease by the factor of K. Right. So if the demand decreases by a factor of K, the optimal lot size also increases by a factor of K. Suppose the demand decreases by a factor of K, this means that it will have an effect on the demand size as well. So when demand grows or shrinks, the optimal order quantity changes, but less than the proportionally. So ordering lots in economic order quantity balances like ordering costs is frequency on which it is ordered, and holding costs are basically the inventory levels. So when demand increases, you need to order more. But because ordering a bit more reduces frequency, you do not need to increase the order size proportion to the demand. So hence, economic order quantity curve is flat near the optimal. So the system is stable, even the demand changes. Here we are just assuming that K is very minimum or minute, so it's not going to affect too much to the overall demand size. So let's take this example in which we have lot size reduces to say 200 units. Now the annual inventory minus related costs are going to be divided by Q, and S plus Q divided by 2 into HC it will make it 250,000. So if the lot size of 200, economic quantity of 200, how much should the ordering cost be reduced? So desired lot size is 200 and annual demand is 1000 into 12, which is 12,000. So, and the unit cost per computers, as we previously discussed, is 500 and holding cost is 0.5. Now putting it here in this formula, we will get HC into Q square divided by 2D. It's going to give us 0.5, 0.2 is the holding cost, 500 is the cost per computer, and Q square is basically 200, which is the economic order quantity we established here. D is the demand. So it gives us 166.7, which is not very different. And then the lot size has to reduce the optimal lot size by a factor of K. The fixed orders cost must be reduced to the factor as well. Okay, so what is going to be the production lot size? From the production perspective, the entire lot does not arrive at the same time. So there has to be a link between production and its output and then the supply. So production occurs at a specified rate, let's say P. Inventory builds up at a rate of, let's say, P minus D. D is the demand. So inventory depleted at a rate of demand. So the more inventory you're going to make and how much inventory has been delivered outside. So we'll have to decrease. Say we are producing 1,000 units in a day and we are delivering 500 units in a day. So our inventory buildup will be 500 per day. Okay, so inventory depleted at a rate of D. So the formula for this production lot size is 2ds divided by 1 minus d h into c. It's basically in many manufacturing settings, products are made internally, not purchased. So this means that the entire lot does not arrive at once. So items are produced and gradually they are at some rate and then they fulfill the demand. If we take the example like there's a production unit that can produce 800 units. So if the demand is 500 units, so they will have 300 units extra being made at the end of the day. Lot size with capacity constraints. So lot size is dependent on the capacity, and if our order size is constrained to say K units, then Q has to be greater than K units. Or if the K quantity demanded is higher than the constraint, so compare the cost of ordering K units and the economic order quantity. And you'll have to look into optimal order size and the minimum of economic order quantity with capacity and capacity K. We have to use like common sense for this. If P is just slightly larger than demand, inventory builds slowly, high holding cost corrections. But if P is much larger than demand, so we need to see like adjust our production Otherwise, we'll have a surplus of huge inventory with us. So the summary of this is that in deciding on an optimal lot size, the supply chain goal is to minimize the total cost, the order cost, the holding cost, and material cost. At lot size increases, so does the annual holding cost also increases. However, the annual order cost and in some instances, the annual material cost decreases with the increase in the lot size. The economic order quantity balances the three costs to obtain the optimal lot size. The larger, the higher the order and the transportation cost, the higher the lot size and cycle inventory. The optimal lot size can be decreased if the fixed cost associated with each lot size is reduced. Okay, guys, this is today's lecture. I hope you understand these concepts. So we'll be more interested about the concepts as compared to the formulas. So if you have any questions, you are welcome to ask. Thank you very much.